In this next example of frame analysis, we've got a portal frame, rigid joints, fixed ends at the bases, but the columns are not the same length. So even though they have the same flexural rigidity, they do not have the same flexural stiffness because of the different lengths, and you have a gravity load that is asymmetric. And oftentimes people think initially when loads are only gravity load that there won't be any sway, but it all depends on the overall symmetry of the problem. Everything would have to be symmetric, the structure of the loads, the foundation, in order for that to have no sway. And we have two levels of asymmetry, both in the load and in the column. So this thing is going to sway. The question always becomes to the left or to the right. You certainly are going to get larger curvatures or larger moments to the closer side of the load, as well as you got a stiff column over here. So I would anticipate the moments at C being larger than, say, the moments at B in this beam. But what does that mean in terms of which way does that tend to cause the beam to sway? So we're going to make just a guess. We have to have, it's going to go left or right. There's only two choices here. And so let's see what happens if we guess that it goes to the right. That'll be our initial guess. Then your deflected shape might look something like you have here, that these columns might have then an S shape, almost certainly would if it goes to the right. Doesn't have to, but we would anticipate that the middle of the beam would try to go downwards. That would cause B to rotate in a clockwise fashion, and C to some extent wanting to try to rotate, not in clockwise, but rather in a, well, which way would it go? This is clockwise. That would probably want to go counterclockwise, even though this is, it's kind of hard to see what might be going on here. But nonetheless, you kind of tend to think that there's going to be an S shape in the columns and some sort of a little bit of smiley face here in the middle. So let's see what happens on that basis alone and see what we can learn. Right? If we draw the moment diagram on the compression side of the member, then the left-hand column will have a moment diagram that looks something like this, reversing over, and then likewise for the right-hand column, same kind of S shape. And that means that with the point load, where we're going to get to some triangular patterns emerging and peaking at under the point load. We've got a match up over here at the left, so outside of the joint because of the column, and then inside of the joint because of the other column. Same magnitude. Right? Remember, that's because of the equilibrium that's suggested. Remember, we're going to draw it on the compression side of the member, so that free body diagram would go along with this moment diagram. Of course, this and that should be the same magnitude. Has to work that way, otherwise we don't have equilibrium. That suggests that we've got positive moment in this side, smiley face of this whole region. We've got frowny face over here. This is going to curve like that, that's going to curve like that, and that would kind of go with sway to the right. But the thing about that is this doesn't feel very good, and that's because I come back to this beam BC. If the columns were super stiff compared to the beam, this would be like a fixed end on either side, and that would mean we'd have smiley face in the middle and frowny face on the end. And that's not what we have drawn here. We don't have any inflection point on the left segment. So that seems a little odd and maybe a little inconsistent. Now, maybe it could happen that way because of the sway, but let's see if we take this out just a little bit further. If we use that sort of 1/10 rule approach, then the inflection points would come in at the 1/10 point of the span. Don't care about that actual magnitude. What I care about is that means that the moment diagram would look something similar to, the 1/10 rule is going to be a little off, right? Because the load is not in the middle. It's not a distributed load. It's, that's partially where we came up with that sort of rule of thumb anyways. But let's just take the overall direction of things and see what it might suggest about the corresponding moment diagrams. We now get, in that case, a negative moment on either end, causing frowny face in the beam. The columns then, to match up, would have to have a moment that's on the same side here, and we still anticipate reverse curvature here in the leftmost column, and we do the same thing over here, and we could guess, hypothesize that we might end up with reverse curvature over there as well. Okay, so I'm just going to redraw that real quick. I'll superpose it. This would be hypothesis B, coming from the 1/10 of the span rule of thumb, and thinking through what might happen there. And we come along and say, all right, let's just redraw that. Why? Just put it all together. That's why. Otherwise, you know, I guess the reason why is, for me anyways, it makes it a little easier to draw the anticipated deflected shape that would go along with this moment diagram if I draw it as a big composite of the beams and columns as opposed to individual ones. I get a little bit better understanding of what this picture might look like. All right, so let's start with the long column, and this says that it curves outwards and then backwards. And so we end up with and I anticipate B again is going to be a clockwise rotation, so even though I had it swaying to the left a little bit, I wanted to make sure that I have the opportunity for that to rotate clockwise. It did end up swaying to the left a little bit. I get the little frowny face in there. Now I got to get the little smiley face in. Got to swing that up so that the frowny face on the far right will actually be possible. Get in there a little rough there, and move the inflection point back to the left just a little bit. And now we got to get our, I don't like that very well. Inflection point should be very little curvature here. And we come along, and I think that's going to rotate counterclockwise. The problem here is that to get the little frowny face, or the curvature that goes there, I'd have to swing this way, and then I got to swing back the other way. But wait a minute, this is curving that way, which should go out, and I'd have to swing that then really sharply around to get it back into that position, which would make, I don't like this at all. This doesn't make any sense at all. This is the delta that goes along with that moment diagram. Now I'm comfortable with this. Suggests maybe it sways to the left. I'm happy with these two. I think the presumption here, though, that we have reverse curvature in the right hand column may be what's causing the trouble and the difficulty in the deflected shape. So let's just hypothesize what happens here. Again, this is all just guesswork based upon some level of experience, yes, but it's trying to make it all work out. Here's maybe again the reverse curvature in the left column, and let's get a moment diagram in the beam. I'm not really doing very good on scale on the moment diagram, but that's okay. We're not worried about scale. We just kind of want to get the right directions of things, right? And if the moment in the column has to be on the same side. The problem was I tried to create reverse curvature. What if I don't do that? What if we do something like that with the rightmost column, that is? That means we get curvature like that, curvature there, curvature, oops. Wait a minute. Drawing on the compression side. Drawing on the compression side, I had that one reverse. There we go. Etc., etc. And we're going to find out that this actually does make a lot more sense as an overall possibility of how things might curve. Because note what we do, we come along and we then put our curvature here at the base of the column. Then we allow this to begin to swing back. We then allow that to create that right angle, and then allow that to kind of come down with the frowny face of this, sway to the left. Then we've got then the smiley face portion. We have then the frowny face portion with the sway. Same amount of sway that we had over to the left. And then we've got all one curvature here, and it looks like we have that much sway. Try to get this all in there. Tangent, let's see, the curvature is the largest at the top. So kind of come in and that looks to me as though in our guess of in C and the delta that would go along, it looks to me like this system is not going to sway to the right. It will in reality sway to the left. Overall, it seems to me to make a lot more sense in the big picture. It is all just a guess. The magnitudes of the moments, though, I would say I'd come along and consider this to be associated with fixed beam with a point load offset, which will be something like PAB over L squared types of moments. Something on that kind of scale of things, maybe PAB squared over L squared, or PA squared B over L squared kind of thing when you look up those fixed end moments. But right now I'm just mostly trying to guess which way does this thing go, and I'm going to declare my guesses to the left.